Okay, we're recording this now. So we're just gonna have to just be really cognizant of the fact that, some of you are in a different place than the rest of you. All the Pierce students are fairly new as well. So this shouldn't be redundant or anything to Pierce students. So the first thing I want to say is that I don't want this to be a lecture. I want everyone to feel comfortable asking questions and interrupting me. This won't be really fun for anyone if I'm just talking at you. So to give a little bit of a breakdown for what FRC is, it's a robotics competition that I guess was founded back in the early 90s to inspire students to take on, roles in STEM fields. And that's, hi. Yeah, we compete in FRC, which is big 120-pound robots. We do, Pierce does compete in First Tech Challenge, which is smaller robots in the fall. And there is like junior high level, I guess in elementary school level, like first Lego League competitions as well. You'll become more familiar with those things as you participate in the program. For first robotics competition, we're going to start competing on January 8th, which is a Saturday. That day is called Kickoff. We have a whole day scheduled out where, pending, anything crazy happening with COVID, we go together to the Allen ISD STEM Center. We will then, watch a game release video where, internationally there's kickoffs all happening simultaneously all over the world, and we're all learning the game at the same time. Once we learn the game and the game manual is released, we will all together go back to Pierce, where we will take part in an activity which we call strategic design. And that's what I'm going to be talking about for the rest of tonight. Strategic design is fundamentally where we do a really thorough analysis of the game that we're playing and how we think all teams will be playing it, and look to find roles for our teams to drive what the robot design will be. So it's a little bit different from something that you might have done in the past. We are, engineering this robot. There is no right answer. We have to find a smart way to play the game to find the success that we're looking for. And every team, us two, as well as, all the others that are playing this game, have different students with different capabilities, working at different schools or community centers, with different manufacturing capabilities. We have teams with different, monetary resources. So everyone's coming to the same game with their own kind of resources and as well as baggage. So one of the things that's going to be important is recognizing, where we are as students and as a team, and not being overly ambitious to the point where it's detrimental to our success at the competition. And for the Richardson students, we compete at our district events. So you'll be competing twice, once in Fort Worth and once in Irving. Pierce team will be competing in Dripping Springs, which is outside of Boston, and at Fort Worth. So we'll be at one event together. There are points that you win at an event that get calculated against everyone else's points to determine if you're going to go on to the district championship, which is in Houston. And then if you do well at the district championship, you can advance to the world championship, which also happens to be in Houston, which is more of a coincidence than anything. So before we can compete, we have to understand the game. And so that's what I'm going to talk about. And I'm going off this presentation, which I will share. You can see my screen. This is a presentation that is pretty famous. It was given by a mentor up in Canada. His name is Karthik Kanegasabath. I'm sorry, I'm butchering this. I won't even try anymore. His name is Karthik. Everyone knows who he is. And he has been giving this presentation for probably a decade now about how to effectively come up with strategic decisions for your team. Does anyone have any questions so far? Okay, so I'm going to keep going, but feel free to interrupt me. I'm going to skip over slides where he's introducing himself. So strategic design, again, we want to do this competition. It's going to be fun. We want to do well at it. But if we don't have a plan, it can go very poorly. And so strategic design is this process that we've set in place for ourselves where we come up with what we want to do to be successful. And this last bullet point is just talking about beware of the cool factor. There are always going to be aspects of the game that are cooler than other aspects. And depending on how we analyze the game and what points there are and how easy or difficult that cool thing is, you might actually be shooting yourself in the foot by focusing on the thing that's cool instead of the thing that's going to help you win. So that's always trips teams up. In the game that we were watching the video of, we had lots of robots shooting these balls, and that was really cool, but it is quite a difficult thing to do. So that's always going to be happening. So once we learn what the game is and the rules are released and we go back to Pierce, the first thing that we're going to do all together is read the rules. And every year we say this, and every year it's very difficult to get everyone to read the rules. But how can you, analyze the game if you don't even understand it? It's something that is just super critical. You're gonna probably skim over some things, and that's just natural. But we really do need to thoroughly understand all the different ways to score points, all the different ways to prevent your opponent from scoring points, understanding ranking, which is not necessarily intuitive. In FRC, they have, in addition to just the points you get in a particular match, they award ranking points to certain tasks. Typically, these are certain tasks that probably can't be completed by a single robot alone. And in FRC, we are competing in every match with 2 alliance partners. So it's 3 robots against 3 other robots for every match. And if you have, good alliance partners, which, for the most part are randomly assigned, you don't have a whole lot of control over the ranking points if it requires multiple robots to do it. But it boils down to a win gets you 2 ranking points. A tie gets you 1 ranking point. A loss gets you 0 ranking points, but there's 2 additional ranking points for these tasks that I'm talking about. And so they're really important. And so understanding those rankings are very important. And adding on to this and talking about ranking, it's very likely that, after all of your qualification matches that you'll play in, that you will be tied in the rankings with other teams. There are tiebreakers that we need to understand to make sure that if we are tied in ranking points, that we will come out ahead with whatever the tiebreaker, first or second tiebreaker is. And then as we understand all the points, as well as all the penalties, we'll start talking about strategies. So not just, we're going to score these points. It's going to be, well, this is actually how a match might play out. First, we're going to drive to this location and do this, and then we're going to drive to this location and do that. And talk about the different robot archetypes, which is just a fancy way of saying what different types of robots will we expect to see at these competitions? How can we compete against them? How can we compete with them? Chokehold strategies. This is pretty obscure at this point. Chokehold strategy is when you do a certain thing and you are guaranteed to win. In past games, a long time ago, there were certain things that teams figured out you could do that would allow them to win a game no matter what. The game designers are really good now, and chokehold strategies don't really exist. So that's why I'm just going to move on. Cost-benefit analysis. So for everything that is possible to do in the game, there is difficulty associated with it. And so when we weigh these points for different tasks against one another, we do have to take into account how difficult it is or easy. And the tasks that we want to hone in on are the ones that give you lots of points and are relatively easy. And that's kind of the sweet spot. In the chat, there's some mention of ducks. And this past first tech challenge game, there was a relatively simple task of delivering ducks. That's what the task was called. And a lot of teams didn't do it. And it didn't really make sense why teams weren't doing it because it gave you so many points. But we did have teams, our 3 FTC teams did a good job of getting those points because they understood the rules and the strategy behind doing that task. Defense is a little bit hit or miss. It depends very much on what the game allows you to do. Sometimes there are more penalties for playing defense than other times, but it is something we need to take into account. This mentions D-scoring. Again, depending on the game, D-scoring may not be allowed at all. So we understand the game at this point, and we now have to come up with 2 lists. We have one list that lists the desired robot qualities, and a second list that lists the desired robot functionality. I want you to focus on two words on this slide. The first one is priority. The order of this list matters very much. We will base our entire season off the order that we write these lists in. Every robot design decision that we make has a trade-off. And so if we say, for example, speed is a higher priority for us than power, that directly impacts how we design the robot. And similarly with robot functionality, if we say one task is a higher priority than another task, so for example, we say shooting balls is more important than climbing bridges, and partway through the season, we find that all our time is being focused on climbing the bridge, then we've messed up because we said shooting balls was more important. Why are we working so hard on climbing bridges? The second word I want you to focus on this page is want. Writing these priority lists are what we want our robot to do. And this has absolutely nothing with robot design. It has nothing to do with how we are going to design the robot or how the robot works, what mechanisms it has. That's actually irrelevant at this stage in creating the list. We want, we know that we want to climb a bridge, but we don't really care about how we're going to do it. Are we going to have, pneumatic climber? Are we going to have some sort of suction flip cup thing that flips us onto the bridge? Those things are irrelevant as we come up with the list. And that's really important because we create these lists based on our analysis of the game, and we build our robots to the list. And so it has to happen in this order. And kind of what I've been saying this whole time, the list determines all direction of design for the season. So on kickoff, on this first day that we're all together and learning the game, we will come up with priority lists for each of our teams, for the Pierce team, for the Richardson team. We will call the list tentative. So the list has the ability to change. It's not set in stone. If we set it in stone, and we realize later that we made a huge mistake, we didn't understand part of the game fully, we do want to have the ability to correct course. As we go through the first couple weeks of the season, teams are sharing a lot of what they're doing, and they may have shown you a way to do something that was way easier than you thought it would have been. So if one of the reasons you chose to organize your priority list a certain ways because you thought something was hard and it turns out it's easy, that could definitely change how you want to target the rest of the time you have before competition. This is kind of a trick question. What is the number one priority on your priority list? So yeah, Rain got it in the chat. The drivetrain is the number one priority. If you can't drive, you can't really do anything else. And there's no way around that. Sometimes we joke about this robot concept called the mega crane, which doesn't have a drivetrain at all, and it just has a giant crane. And that crane is able to extend whatever needs to be done. But that's never really a good plan. What should the number two priority on your priority list be? Someone other than Rain. Alexander says manipulator. That is not correct. Any other guesses? All right. The number 2 and the number 3 priority are also drivetrain because that's how important it is. That's why it's a trick question. I disagree with this, so I'm going to move on. As we talk about design, we really have to understand our team's limits. So golden rule number 1, always build within your team's limits. I think this is single-handedly the most difficult thing to do in FRC. Teams always tend to overshoot their limits, and it ends up backfiring. And it backfires because if you say you're going to go do all these things, you want your robot to do all these things, and you are spread too thin, then you will do all of those things poorly. And it's much better to do things well, to do a few things well than to do many things poorly. And so for this is actually something on the Pierce team that the mentors do. We've already done it for this upcoming season. We've said that, beyond having a drivetrain, we're going to have 2 mechanisms and no more than 2 mechanisms. We have no idea what the game is. We don't know how easy or hard different tasks are going to be, but based on, our evaluation of our team's manpower, budget, experience, we don't believe that we could successfully implement more than 2 mechanisms on our robot. For the Richardson team, this is really impossible to do because none of you have been working together before. You have no competitive robotics experience, and everyone's still learning each other and learning their capabilities. So for that reason, we'll talk about later, we want to be very cautious with what you guys are working on. We still want you to have a good time. And so that makes it really important to focus on some simple tasks in the game. Rain is asking if I'm counting an intake, arm, indexer as separate mechanisms. And the answer is yes. So for example, for the last robot that we built before COVID, we had a climber, we had a shooter, we had an indexer, and that robot would have been 3 mechanisms, which at this point, I don't want us building a robot with 3 mechanisms, so we would have to build something simpler. Golden rule number 2, and this is just building on what I just said. If you have 30 units of robot and functions, and each function has a maximum of 10 units, it's better to have those 3 maxed out at 10 of 10 instead of having 5 different functions at 6 of 10. So again, we want to focus on simplicity. We want to focus on doing things well instead of just doing a lot of things. So quality over quantity. As we design, there's always going to be trade-offs. And the key thing to understand about trade-offs is that, every person, every team is going to look at those trade-offs differently, and the decisions that they're going to make are going to be different. So you're going to, have the opportunity to see teams who are, transparent and sharing their robot builds as they go along. And it's not enough to say, oh, they did this, we should do that. You really have to take the time to understand why they made the decisions that they made, if those decisions are different than ours. So this all goes back to the planning. If our analysis is bad at the beginning of the season, it's just going to make everything, going forward more difficult. And again, this last sentence, there's no shame in building a simple robot. Simple robots do well at the competitions. And I think it always, there's always some people that are surprised by it. Just because when you build something that's simple, you're able to put in time getting the programming done, getting driver practice, really thinking through strategy, because you aren't burdened with the stress of a more complicated robot. And then the only thing on this slide I'll focus on is let your strategic priorities dictate design. So those strategic priorities were the lists that we came up with. And if we diverge from those lists, we are making a huge mistake. All this slide is saying is don't skip the step of strategic design. You must know what you want to do before you can figure out how to do it. I'll preach this. I'll say this a lot. We have to figure out what we want to do before we can figure out how to do it. In order to do this strategic design, we have to make a lot of assumptions based on experience. We will use rules of thumb. How long does it actually take to do a certain task is something that is always easy to overestimate. You'll say, oh, I can do that in 10 seconds. And then you build your robot and it actually takes 30 seconds, which results in quite a difference in scoring if you are relying on that 10-second cycle time. So it's better to be conservative when we're considering cycle times. As we do strategic design, we do have to understand that we will be competing with other robots. I think the Pierce students learned a lot about this at their first Tech Challenge events. They had, sometimes they had really good alliance partners that were able to, score a lot of points, and sometimes they had, bad alliance partners that weren't as good. And kind of the worst thing that could happen is when you have partners that tell you they can do something, and then it's only once the match is happening that you realize that they actually can't do it. So really having those honest conversations ahead of time with your partners is going to be something that we talk about when it gets to scouting and actual match planning later on in the season. As we do this analysis, it's a little bit redundant. We'll talk about the different robots. This is the robot archetypes I was talking about. We have different combinations of different robots. How do we win? I think that's where I'm going to stop on this particular slide deck. Scouting, for those of you new to this, is where we have students at the event watching all the matches and taking data on what's happening for each robot in the match, and using that data to drive strategic decisions when we are either partnered with those robots that we've been scouting or going against those robots that we've been scouting. And it's really essential when we go to the playoffs, because in the playoffs, we pick our alliance partners. So the teams that are ranked at the top will be alliance captains, and they will pick the robots that they want to play with. So they'll pick 2 or 3 other robots that they want to play with for the rest of the playoffs. And you want to pick robots that are really good, and scouting enables that. So I'm going to move on from this presentation. Does anyone have any questions about strategic design? No one. Come on. I need one question. Rain asked in the chat, what do I think the biggest thing teams overlook? I don't think it's that teams tend to overlook things. I think it's that teams tend to get distracted. It's really easy to either get caught up in what's cool, or get distracted by a mechanism or a task that's more difficult. So they know they want to do it, they have it on their priority list, and they're doing this difficult thing, and they're forgetting to do the easy things first because they tell themselves they could figure out the easy part later. And so my advice is just, if it's easy, finish it, get it done with. Let the programmers program it, let the drivers practice with it while you're working on the thing that's more difficult. All right. I am going to switch over to this blog post. This blog is not an active blog, but it was written by a mentor. His name is JVN, that's what he goes by. He's a mentor up in Greenville, Texas. He's pretty well known. He kept a blog in like the 2018, 2019 seasons of what his team was doing. His team is one of the best in the world, so it's fairly relevant and powerful. They talk about this game breakdown, the strategic design that we've been talking about. His step 1, play dodgeball. This is a reminder that we want to have fun. We want to, enjoy being a part of the team. Because some of this analysis stuff can be more difficult. And if we're not, good friends and on the same page, it just makes it even more difficult. Step 2, watch the broadcast. This is what we're all going to do together. This is where we learn the game. On the robot rules, we'll read the rules. They break it down as basically categorizing design constraints. So in the rules, they have a whole section called robot rules. And this is related to and these rules are usually pretty similar year to year, but they're not always the same. And so we want to understand what is different in this particular year. So robot size could be different from a previous year. So we have to keep that in mind. Expansion rules. So typically the robot has to start within a certain size, and it can expand to a different size once the match has started. Robot weight, it's typically 125 pounds. Maybe it's different this year. For energy, We typically have the same batteries. We typically have the same motors and electrical components and pneumatic components and passive components that we're allowed to use on the robot, but maybe this year's different. How many actuators or motors or pneumatic cylinders are we allowed to have on the robot? That's important to know. For control system, the control system typically is what it is. The rules around it won't be particularly surprising. The bumper rules. So because these robots are large, because they will be ramming into one another, they require you to build bumpers, and they tell you exactly where the bumpers need to be mounted, how big they are, how they need to be constructed. There are typically cost limits on, so like a single part could not cost more than, in this example, $500. This year, they already announced that it's going to be $600, which there's nothing that expensive that we'd be buying. And as far as I'm aware, there will not be a maximum cost for all the components on the robot, which is not a number that we ever hit anyways, so it never really affected us. Possession rules, how many objects are you allowed to carry at a time? If there are multiple different objects in the game, what are the rules about carrying each of those? And then there's always this gray area of what it means to possess or control a game object, and that will be different from year to year. Sometimes it's fine if you run into an object that's laying on the ground. Other times, that might be considered controlled and you could get penalties for that. Are there any other rules that stand out? This could be penalties. This could be, a specific rule on, launching game pieces. Sometimes it's allowed, sometimes it's not. For, all of you who are new to FRC, you're not really going to be familiar with what past game manuals were written like. So, everything will be new to you, which is fine. It just means you have to pay even closer attention to the rule book. Once we've done that, so that's like a high level, what are the robot rules, penalties? We start looking at the field. We start looking at where the robots start. We start looking at initial field setup. So sometimes game manual or game elements will start in different places of the field. It's really important to understand. Hold on, my battery's dying. Need to plug in. Sorry about that. Where do we score? What obstacles are on the field? Different areas of the field will have different restrictions. So sometimes there'll be like alliance-specific zones that alliance is allowed to be in. And if they are hit by an opponent while they're in that zone, it can result in pretty big penalties. So understanding where you're allowed to be on the field and when is really important. We have autonomous. So in first tech challenge, we had 30 seconds of autonomous where the robot's completely controlled with the code that we write and the driver is not doing anything. In FRC, in the first robotics competition, we have 15 seconds. So that time is even more critical because those points are generally worth more. So doing a specific task is generally worth more when you do it in autonomous, and we want those points. So in order to enable robots to do things autonomously on the field, the game designers will include different vision targets, potentially, that allow you to use a camera or other sensor to lock on and perform a task autonomously. We need to understand just the overall time limits. The games can be scored very differently from one another. So sometimes you get, X number of points for doing this task. If you do the task 10 times, then you have 10x points. But it's not always like that. Sometimes it's time-based. So you score this object and you get points for the number of seconds that that object is scored for. And the other alliance can descore it, so you are no longer receiving points at that time. Or you could have really staggered scoring, where for the first thing you score, you get 1 point, and for the second thing you score, you get 0 points. But for the fourth thing you score, you get more points, and it's really difficult to analyze those sort of games, because you're not really sure how many you're going to be able to score or how many your alliance is going to be able to score. So it makes the strategy element of it quite difficult. And then robot field interaction. So what can you grab? When can you grab it? Typically for these FRC games, they're broken out into three sections. So there's the autonomous mode, where the robot's operating on its own. Then there's the driver controlled mode, which is the rest of the match. The last 30 seconds of the driver controlled mode is what is called end game. And there are typically tasks that you can only do in end game. A lot of the time, those tasks are climbing tasks. So climb up onto a ledge, climb up, grab a bar and raise yourself to a certain height. Sometimes it's balancing on something that's not easy to balance. So the rules around those robot to field interactions are important, because sometimes you can think up a strategy of how to do something only to find out that it is not legal to do that. Scoring analysis. This gets into what we spent a lot of time talking about already: understanding the scoring, understanding the ranking, understanding the penalties, looking at what you think a maximum score might be for the game. I'm not sure what he's referencing here. And then game cycles, how fast will a good robot score? How fast will an elite robot score? How fast will a bad robot score? Typically, speaking of loading stations, typically there are two ways to obtain a game element in a particular game. You can drive over to the wall where a human player can actually load the game element into your robot, or you can pick it up off the ground. And so that's always going to be a trade-off, as usually picking up off the ground is faster than going to the human player, but it typically requires an extra mechanism to do that. Setting your goals. So this is something that's obviously important as a part of the priorities. Really, you want your priorities to get you to your goals. So definitely something to think about as a team. What do you want your goals to be? For 1745 for the Pierce team, one of our kind of typical goals is that we want to advance to the district championship. So getting enough, managing to do well enough at an event that we get those district points and we can advance to the district championship. It's a pretty straightforward one. That's where I'm going to stop on this page. Does anyone have any questions? All right. I want to touch on a couple of things. I'm just jumping around a lot here, I know. The process through which we come up with our priority lists after we've done all this game analysis is really difficult. It can be quite intense if different people have strong feelings about doing different things. And so this ultimately comes down to teamwork and group decision-making. We want to be able to build consensus among all the team members so that one way or another, we're all on the same page about what we want to be spending the rest of the semester doing. If you have an opinion, you should be able to back it up with analysis. There is an important component of experience that is difficult to take into account because, you know, we have mentors that have been doing this for, you know, many, many years. We have kind of good gut intuition as to what is difficult and what is hard that you may not have. And we will try to convey that quantitatively as to why a certain task may be more difficult than another task. And if that, you know, persuasion is not effective, then it can, you know, lead to disagreements or lead to, you know, making decisions that aren't really effective later on. So, you know, team building is really important just because when we get to situations where, you know, we have to make hard decisions, you know, if everyone knows that their team members have the best intentions, even if they're disagreeing, it makes things move a lot more smoothly. And then lastly, I just want to leave you with this. Robots don't win competitions, period. Teams do. This is another thing that, you know, I would preach to anyone that asks. It's really easy to get caught up in the robot, to always be working on the robot and not really giving the driver time to practice or the programmers time to program. And the teams that are always working on the robot, always trying to make it better, end up doing worse than the teams that look at the problem more holistically and give equal time to the programmers, equal time to the drivers, really trust their strategists and their scouts. Those are the teams that do well. And you'll see teams that do well every year. And they're not doing well because they're just better at designing robots. I mean, some of them may be, but they're really doing better because they really take a team approach to the competition. That's the last formal thing I have to present. I'm really looking forward to meeting all of the Richardson students. I want to continue this conversation right now, and we'll continue it on later dates over winter break. But now this is really just like a free-for-all. I want you to ask questions about things you might have heard that you don't understand, or we can talk more about the competition in general, since many of you are not familiar with the competition at all. I'm going to stop sharing, and we can stop recording. And